Good morning. Today's lesson will be about arithmetic sequences. We will be discussing how to generate patterns and how to illustrate and define what an arithmetic sequence is. As discussed in the introduction part of the module, arithmetic sequences are sequences that has the common difference. Each term of the sequence is obtained by adding a constant term to the preceding term of the sequence. Shown on the screen is an example of an arithmetic sequence. We have 4, 9, 14, 19, and 24. So we need to generate the next two terms of the arithmetic sequence. So the big question is, how? So the first thing that you need to do is to get the common difference. So how can we get the common difference? Going back to the sequence, you just need to subtract the second term by the first term, the third term by the second term, the fourth term by the third term, and so on. In this example, we will have 9 minus 4 is equal to 5. 14 minus 9 is also equal to 5. 19 minus 14 is also equal to 5. And 24 minus 19 is also equal to 5. Notice that all the answers are the same. So therefore, 5 is the common difference. So for us to get the next terms of the arithmetic sequence, we just need to add the common difference, which is 5, to the last term of the sequence. So we will have 24 plus the common difference 5, so that is equal to 29. So therefore, 29 is the next term of the arithmetic sequence. Now for us to get the next term, we just need to add again the common difference. So we will have 29 plus 5 is equal to 34. So 34 is the next term of the arithmetic sequence. You may pause the video if you want to copy the example. Next, we have the sequence 8, 5, 2, -1, and -4. Again, we need to determine the next two terms of this arithmetic sequence. First, find the common difference. That is correct. So that is 5 minus 8 is -3. 2 minus 5 is -3. -1 minus 2 is -3. -4 minus -1 is also -3. So the common difference of this arithmetic sequence is -3. So for us to get the next two terms, we need to add the common difference to the last term of the sequence. So we will have 4 plus -3, since both are negative, so our answer will be negative. Then add two numbers, 4 plus 3, so that is -7. So therefore, -7 is the next term of the arithmetic sequence. Next, to get the next term, we will have -7 plus -3 is also equal to -10. So therefore, -10 will be the last term of the sequence. Again, you may pause the video if you want to copy the example. Next one, we have -5, -1, +3, and +7. We need to determine again the next two terms of this arithmetic sequence. First, get the common difference. So that will be -1 minus -5. You may use your calculators. -1 minus -5, so that is +4. 3 minus -1 is +4, and 7 minus 3 is also +4. So it is shown that the common difference is +4. So to get the next terms, you just need to add. So we have 7 plus the common difference positive 4 equals 11. So therefore, 11 is the next term of the sequence. The next 11 plus positive 4 equals 15. So therefore, 15 is the sixth term of the sequence. How can we determine if a sequence is an arithmetic sequence or not? Let us try the following examples. Negative 5, negative 1, positive 3, and positive 7. Just like the previous examples, we just need to determine whether there is a common difference. So we will have the second term minus the first term. So that is negative 1 minus negative 5. Since both are negative, so this will now be equal to negative times negative is positive. So this will be negative 1 plus 5, and that is equal to positive 4. Next, the third term minus the second term rather. So that is 3 minus negative 1. So this will be again negative times negative. So this will be 3 plus 1. It is also equal to 4. And the fourth term minus the third term. So that is just 7 minus 3. Again is equal to 4. Notice that all the differences are the same. So therefore, there is a common difference. Going back to the definition of an arithmetic sequence, so therefore, this sequence is an arithmetic sequence. The reason why? Because it has a common difference. Let's try another example. We have positive 2, positive 6, positive 9, and positive 14. So let us try to check whether this sequence is an arithmetic sequence or not. So we need to check for the common difference. So again, subtract the second term and the first term. So we have 6 minus 2 is equal to 4. Then next, the third term minus the second term. So 9 minus 6 is equal to 3. And 14 minus 9 is equal to 5. Since we do not have the same differences, therefore, this sequence is not an arithmetic sequence because they do not have a common or a constant difference. For the third and the last example, let us try using fractions. So we have 1/3, 5 over 6, 4 over 3, and 11 over 6. So let us try to verify whether this sequence is an arithmetic sequence or not. So we have to subtract the second term and the first term. So that is 5 over 6 minus 1/3. Since this is a dissimilar fraction, meaning it doesn't have the same denominator, we can just use the shortcut, which is by cross multiplication. So we will have 5 times 3 is equal to 15. Copy the same operation minus 1 times 6 is 6. Then for us to get the denominator, we'll just multiply the two denominators. So we will have 6 times 3 equals 18. Then simplify. 15 minus 6 will give us 9. Then copy the denominator, 18. 9 over 18 can be simplified. Since both are divisible by 9, so 9 divided by 9 is 1, and 18 divided by 9 is 2. So therefore, the simplest form of 9 over 18 is 1/2. So the first difference is 1/2. Let us try for the next. So 4 over 3 minus 5 over 6. Again, these are the similar fractions. So we will just use the same procedure. So we have 4 times 6 is 24 minus 5 times 3 is 15. Then multiply the two denominators. 3 times 6 is 18. Then simplify. 24 minus 15 is 9 over, copy the same denominator, 18. And again, 9 over 18 in simplest form is 1/2. So therefore, the second difference is 1/2. And for the last one, we have 11 over 6 minus 4 over 3. Again, those are the similar fractions. So the same procedure. 11 times 3 is 33. 4 times 6 is 24. Then multiply the two denominator. 6 times 3 is 18. 33 minus 24 is 9 over, copy the same denominator, 18. Again, 9 over 18, and simplest form is 1/2. Since we have the same differences, or we have a constant difference between each term of the sequence, so therefore, this sequence is an arithmetic sequence. So if you have any question, you may send me a message through your Schoology account. Thank you.